Okay, let's just dive right into this explainer by asking a super simple question. You know when you hear buzzwords like AI, machine learning, and deep learning thrown around at work, or constantly in the news, are people just talking about the exact same thing?
It's honestly incredibly easy to mix them up because they are so closely related. But the truth is, they're not competing technologies. And they definitely aren't just fancy synonyms for a smart computer. Actually, as we're going to explore today, they are a series of beautifully nested layers of intelligence. Each one is more specialized, way more data hungry, and far more complex than the last.
So here is our map of intelligence for today. We'll start at the broad outer shell of AI, dive into machine learning, plunge straight into the neural core of deep learning, and finally zoom back out to look at narrow versus general AI and how you actually go about choosing the right tool.
All right, let's start with Section 1, AI, the outer shell.
Artificial intelligence is this massive conceptual umbrella that covers literally any system that simulates human cognitive functions. And what's kind of wild about this is that AI doesn't always mean a system is actually learning anything at all. It totally includes basic deterministic rule-based algorithms. Like, if a human sits down and writes a strict set of logical rules for a machine to follow to solve a problem, boom, that is still AI.
To make this super concrete, think of one of those early basic smart vacuum cleaners. It doesn't actually learn your floor plan, right? It just follows a strict pre-programmed rule. Bump into a wall, turn 90 degrees, move forward. That's it. It's just following human logic. So while it totally appears intelligent and automates a chore for you, it's completely static. But technically speaking, it is absolutely artificial intelligence.
And this outer shell of AI is so incredibly useful for general automation and rule-based logic that in 2024, a staggering 78% of organizations reported using some form of AI in at least one business function. Seriously, it is everywhere.
But, well, what happens when rigid rules just aren't enough? That brings us to Section 2, ML, learning from data.
This is machine learning. And guys, this represents a massive philosophical shift in computer science. Instead of a human programmer painstakingly writing down every single explicit rule, we essentially hand the computer a massive spreadsheet of historical data and just say, hey, you figure out the rules. The system actually gains experience and infers its own logic just by finding patterns in that data.
This is amazingly practical for spotting trends in structured data that we humans might completely miss. I mean, it's exactly how Spotify curates your Discover Weekly playlist by clustering your listening habits with similar users. And it's how a massive 83% of banks currently use ML to detect financial crimes. The machine learns what a normal transaction looks like over time, so it can instantly flag an abnormal one. Pretty clever, right?
Going back to our smart vacuum analogy, if you upgrade to a machine learning vacuum, well, it no longer just bumps and turns. It actually uses sensors to build a digital map of your room over several runs. It learns from experience which areas get the dirtiest and then adjusts its path for maximum efficiency. So it is learning, absolutely, but it's still relying on structured data and clear human-defined parameters.
Okay, but what if the data is just messy, raw, and totally chaotic? Let's plunge into Section 3, DL, the neural core. Deep learning is the deepest, most complex, nested layer. It's literally inspired by the biological structure of the human brain. It uses millions, sometimes even billions of these interconnected artificial neurons or nodes. And they're arranged in multiple hidden layers to handle massive volumes of completely unstructured information, passing signals deeper and deeper into the network.
Now, the absolute core operational difference between machine learning and deep learning, it comes down to something called feature engineering. With standard machine learning, a human actually has to manually tag and label the data so the machine knows what to look at. Deep learning, on the other hand, automatically extracts those features directly from raw data as it flows through those hidden layers. It literally figures out what matters all on its own.
And let me tell you, this autonomous feature extraction is absolutely crucial. Why? Because an estimated 80% of an organization's data is completely unstructured. We are talking about raw images, massive text documents, video clips, audio files. Traditional ML completely chokes on this stuff. But this chaotic, raw data, that is exactly where deep learning shines.
Because these neural networks scale so beautifully with more data and more computational power, these deep models are advancing at a terrifyingly fast pace. Consider this. On the WSC Bench complex coding task, AI systems jumped from a mere 4.4% success rate in 2023 to a staggering 71.7% in just a single year. That is the raw power of deep learning architectures processing vast amounts of unstructured data. To wrap up our vacuum analogy here, a deep learning vacuum doesn't just map a room. It uses a camera, computer vision, and neural networks to actually identify objects in real time. It processes raw pixels to understand the difference between, say, a table leg, which it should clean around, and a sleeping dog, which it should absolutely avoid. It is interpreting the real world autonomously.
Now that we've reached the very core, let's zoom all the way back out for Section 4, Narrow versus General AI.
Look, it is vital to understand that every single nested layer we just explored, from that basic rule-based vacuum all the way down to the deepest, most mind-bending neural network powering something like ChatGPT, all of it currently exists strictly within the realm of artificial narrow intelligence, or ANI. We definitely have not achieved the next steps on this timeline yet.
So, the crucial takeaway here is understanding this limitation. While our current narrow AI tools are incredibly powerful at specific, isolated tasks like generating text, driving a car, or detecting fraud, they are ultimately rigid. A fraud detection algorithm cannot suddenly decide to write a beautiful poem. They completely lack the cross-domain reasoning, the common sense, and the fluid adaptability of theoretical artificial general intelligence, which would rival actual human cognitive flexibility. Because we are still operating in a world of specialized AI, applying this technology requires a really strategic framework. So, let's look at Section 5, choosing the right tool. When you're comparing these tools, think about it like this. If you're a bank dealing with structured financial data and you need a transparent, highly interpretable model so you can explain to regulators exactly why a loan was denied, standard machine learning is absolutely a perfect tool. But if you're building a self-driving car that needs to instantly process massive unstructured video feeds, you just have to absorb the high computational costs and the whole black box nature of deep learning. Ultimately, understanding these nested layers isn't just some academic vocabulary exercise. It's a strategic framework for knowing which tool solves which problem. You really have to match the right tool to your specific problem, balancing your available computational resources and data with your need for transparency. Basically, you don't need a massive, power-hungry deep neural network, just a sort of simple spreadsheet.
So as we look at how fast the neural core of deep learning is expanding its capabilities, I want to leave you with this final thought. As we continue to refine these incredible nested systems, we really have to ask ourselves, are these narrow layers just insulated stepping stones? Or are they the actual building blocks that will soon fuse together to unlock true, adaptable, human-level artificial general intelligence? It's a fascinating question, and honestly, one we're getting closer to answering every single day. Thanks so much for joining me on this explainer, and keep learning.